the sigma notation leads to the integral. It's kind of like the secant line, or that's like the slope you're used to leads to the derivative. It's kind of analogous to that, but this is almost all done on a calculator.
Oh,
Like
okay.
this first one we can do by hand, but you're going to see like there are ones where you just can't do them. Although I mean, these are all kind of small. So the way this works is you first say, okay, let I equals 1, and then you put I equals 1 into 3 times 1 plus 2, which is 5. Okay, so the sum equals 5 plus. So that's the sigma means sum or add them all up. And then you increment I, so I is now 2, and then you put I equals 2 into the equation. 3 times 2 plus 2 is 8. So 5 plus 8. And then you continue. So you let I equal 3. 3 times 3 plus 2 is 11. And sometimes you can detect the patterns, so like you don't have to keep putting in the I, but the I equals 1 is your start. The I equals 6 is your stop. You're going all the way up to 6. So for I equals 4, it's 14. For I equals 5, it's 17. For I equals 6, it's 20. And then you add up all of those numbers there.
Okay. Just add them all up.
So not much more to say on that. Is there I just start at 5 arbitrarily. Is there one that you need us to look at from like 6, 7, or 8 to talk about?
Nope.
These can all be done in your TI 83, 84. There's a sum sequence that you have to do. I could probably show you that if you wanted. There's a million online calculators as well for this.
Do you know if you could do it on a TI Inspire?
Yes, I'm sure you can.
Okay.
Let me check that real quick. Yeah, so do you like videos or more of screenshots?
Either one. It doesn't matter.
Okay. This one looks pretty good. Sort of going off the Google search here. So drop that in there.
Perfect.
That one's kind of a longer video, but it looks like you got to go
The
find
idea of having
Yes.
you got to find the sigma button, and then it looks like you just enter in like either I or N. Sometimes use N instead of I, lower, upper, start, stop the formula, and then it does it for you.
Okay.
So on a test, like, I mean, I would probably, I don't know what I would do on a test to make this where you could use a calculator, but you may just be writing out the sum. You may actually have to find the sum. Things like that. So, okay. So the next, what's the next kind of grouping of questions here? Okay, so it's going backwards now. That's actually more of a test question going backwards, where you write the sum.
Oh, like 11 or 12.
Yeah. So we can go to those next, unless you have
Nope, that's
something
fine.
else. Okay, so let me look at 11. I always tell students that this isn't really math, it's pattern recognition, which some people think it's related to math. I don't know, but you got to be careful here to not like. It's just sometimes they're just hard. So you always figure out what's the same and what's different. Like all of these have a 1 in the top, all of them have a 5 in the bottom. What's different is it goes up by 1 to 2, 2 to 3, and so on. So because it's a plus, that's how you know it's a sigma.
Okay.
Greek letter sigma. I don't know if you're in a sorority fraternity. I don't really know where sigma fits in that world. Then you got to write the formula. So it's always 1/5. And then the thing that's changing each time, so this 1 to 2 to 3, that's what's changing. That's typically your variable. Now, I is common, N is common. You could even use X. And so now you got to figure out, what does it start at? What does it stop at? So you can see the first value of I is 1. The last value is 11.
Okay. Yeah, that makes sense.
And you can also like put the I's in and make sure that that it works out.
So if you were to make this a question on the test, how would they expect you to show your work for something like this?
Uh, it's hard. You'd have to like write the sequence, or you'd have to write the sequence like AI equals 1/5i, and then maybe just say, okay, A1 is 1/5 times 1. Yeah, maybe that's a little bit of work.
Okay.
It's not great.
Yeah, I was gonna say I don't know how he expects us to do like a lot of work for this kind of problem.
It's tough. It's tough. So let's look at like, I don't know, pick a little more difficult one, like maybe 14, since you don't have the answer to that one. All right, so again, you kind of look like what's the same, what's different, what's changing, what's not changing.
Uh, the 1 minus and then the 4 on the bottom and then squared.
Yeah, so you can start saying it's 1 minus, and you just write the stuff that isn't changing there. Sigma means the plus. And then, you can start, okay, I is there because it's going from 1 to 2 to 4. So I equals 1 to 4, like that.
Yeah, that makes sense. Sorry, my dog is just barking.
So really, I mean, really not that difficult. I mean,
Yeah.
why don't you try 12 or 13? Why don't you try, I don't know. I don't know, why don't you try 12? Just
So sigma 6 over 2 plus I. And then it stops at 11 and starts at 1.
yeah, so I equals 1 to 11, 6 over 2 plus I, like
Yep.
that. You can put parentheses around it or not. That's really good. Okay, so the next grouping of problems, this says to use a graphing calculator, but we can do a few of these by hand. I mean, I mean, like, you can go to the Inspire if you want, do this, but like if you just see a constant number means when I is 1, it's -8, plus when I is 1, it's -8, plus when I is 1, it's -8, plus, and so on. So it's -8 times 20. Because there's 20 of them.
Okay.
But I would maybe spend a moment figuring out how to do the sigma on the inspire.
Okay.
Once you see it.
Menu.
At all, you could just use what I'm about to tell you to do that. So this video will be dedicated to finding the convergence or divergence of a series, and then the, if it is one or the other, the place where that happens. So let's open a calculator tab. So menu 1, and let's deal with a good old function sequence 1/2 to the n. All right, so we want the sum of the series. So we want the sum of all a of n values from 1 to infinity. So that's going to be sigma. So let's go menu. We're going to go to calculus 5, which is sum. And look at that, we get a sigma. So we're going to go n equals 1. That's our starting point. And then we're going to go control and the little book. It's like catalog. And you can find the infinity, select it, and hit enter. And we want that on top. And then our function or our sequence in the parentheses. 1/2n. And if you remember correctly, we should get 1 as our answer. There you go. 1. So this is a pretty basic power sequence. This also
Yeah, so mine says unsupported feature. This feature requires computer algebra system TI Inspire CAS. I think I just have to use, I have a TI-84. I just have to find it, but I can just do it on there.
Right.
Like,
I mean, there are literally like any calculator you ever need is available on the internet.
yeah, right. So if I can't
So
find it, it's not
you
a,
can't find it. Yeah.
yeah.
It's, so the next grouping of problems really requires you to have technology. But I can find a calculator or show you that online here. So for this one, it says basically do this, but go up to n. Well, what is n? And they're like, okay, well, do it for n, 10, 100, 1,000, and 10,000. So it's almost like a table. It's like, okay, n equals sigma equals for 10, 100. Oops, an extra 0 there. 1,000, 10,000. You can go up even more, right? And what you should notice is that these converge to the same value. It's kind of the Pareto principle in some ways, where like the bigger ones don't contribute, like more contributes from the beginning than at the end. So let me see if I can find an online Sigma calculator. Oh boy. Okay, yeah, I mean here's one here. So I'll just drop this in the chat. And
Yeah, I'm
go
wondering how
together.
he expected us to just use a basic calculator when we need one that.
There are formulas for these, but they're not used.
Yeah, because originally he was gonna have us just use like one of those like basic
Yeah.
calculators.
So actually, I'm so just, everything's a nightmare right now. All right, that's in the chat. So we're gonna do this problem. And it's, you get like, again, you get there's little variations, like it says n equals and then k equals, at the top, it's really n. You want to use whatever letter, so 2n plus 1 over n squared. And then we're going from 1 to 10. So we're going to calculate that. Where is the sum? Okay, so there's the sum. So the sum is like 7.41. Okay, and then I'm going to go to 100. Oh. And then it becomes 12.01. I'm writing this down. And then 1,000. 16. So this one's actually growing forever, which is not good. I actually expected this to kind of bound, but it's not. 21, huh? That's weird. Oh, you know what? What's odd about this example, and this might be something, let me go back to the screen because I don't know if this is an error or not. What's odd about this example is they have I and N in there. And that's really odd. Typically only one variable's in here. So these are not correct. So let me redo it where let me put K there and equals 1 to 10. So let me, and again, that's kind of where you get these calculators sometimes don't, they give you, they don't give you necessarily what you want. Calculate. Or you try to use them and they don't work. Oh boy, is it like that? All right, 10. Calculate. Okay, so this first one is 1.2. And then this is 102. Huh. 1,000. Let me go back here. So that one. Yeah, 1.02. Okay, so this is what we're expecting to see, which is where it kind of starts converging to the same value. This one actually is working. So I guess I don't know what to say. I would probably throw out an email to your instructor. I'd probably ask my instructor, hey, are we gonna have to do problems like the ones here in this section on the test, or get a
Okay.
little better gauge of that? Because right now I don't know where to direct you to do these. But just to be clear, so like for what I did for n equals 10, I'm kind of not showing you what I'm doing. For n equals 10, it's I equals 1 to 10. So for n equals 10, so it is 2i plus 1, but you have to put 10 squared in the bottom,
Okay.
which is a little odd. Like usually it's just the letter here that goes in here. And then for n equals 100, it's sigma I equals 1 to 100. So 2i plus 1, but now it's over 100 squared. So you're literally putting that n value in there each time.
Okay.
Which is a little odd, but this one ends up converging to about 1.02 roughly, or right there.
Yeah.
Okay. So we've got like another one here where again it's like if you let n equals 10, what that means is sigma j equals 1. So you can use different letters besides I. You can use I, j, sometimes cn, 7j plus 4. So this is the variable here. And then this time it's over 10 squared again.
Right.
And, and then so on. For n equals 100, it would be roughly the same. J equals 1 to 100, 7j plus 4 over 100 squared. And you'd have to make this change each time in your calculator. You'd have to, it wouldn't be so all right. So this 47 through 53 is like all the summation leads to the integrals. And there's the 47 through 53 here is this could be a test question. So normally I want to say this, normally the you could do a sum here. Let me, sorry. So I need to look this up. This is one of those things that you almost never do. You do one time and then you never do it again. So let me look up the limit process to find the area, because it's a very specific. Where's the examples? Right. So first thing is there's this delta x is b minus a over n. And so this is a and this is b. And then this n, you're taking the limit as n goes to infinity. So like think of n as being like 4, think of like 4 subintervals. And then if it's like 8, that's 8 subintervals and so on. So you're like breaking this up into like these little rectangles. Was that at all covered in the
Yeah.
class?
Yeah.
Oh, that's good. That's good. So then the next thing is you have to write out the sigma notation. So it's n equals 1 to infinity. And the limit, sorry, n equals, it's sorry, I equals 1 to n, sorry, not n, not I, because we're going to index by I. N goes to infinity, meaning like this goes on forever. And why can't I find an example? Sorry, this never, no one ever does this. It's like there's these epsilon delta proofs that no one does anymore in this class. And so anytime I get asked, I have to go look it up because I don't remember.
No, that's okay.
So let me go find one. Thank goodness we have the internet. What I would do without it.
Right.
So then it's f of what's called a CI delta x. And so we kind of already have delta x. Delta x is 1 minus 0 over n, so it's 1 over n. And then f of CI, that's what I was looking for here, trying to find this, is f of a plus I b minus a over n. So it looks really this is your function up here, your f of x. So your function in this problem is 0 for, I'm sorry, it's 0 plus I, b minus a over n is 1 over n. So your f of CI is 0 plus I times 1 over n, so just I over n like that. And then that is what goes into the function. So you put this I over n into the minus 4 x plus 5. So this ends up going in there. So it's a minus 4i over n plus 5. So it's the limit as n goes to infinity, sigma I equals 1 to n, and then minus 4i over n plus 5 times 1 over n. And that's what you will probably get a question like this where you have to write this and this.
Okay.
So you should do a few more examples because that was a terrible explanation, and we'll try to do better. Try to do better this time.
That's okay.
So the key is, let's look at 48. It's you have to know this formula for delta x, and you have to know this formula for this one right here, and then you have to know this one right here. You can see the pieces, you know, the delta x goes there, ci goes there. So for this one, a b, so delta x b minus a over n, 5 minus 2 over n, which is 3 over n. Then f of ci is f of a plus I b minus a over n. So it's f of 2 plus I, and then you already have the b minus a over n here, so it's 3 over n like this. And so now you're putting this 2 plus 3i over n, 2 plus 3i over n, you're putting that back into the function here. So it's 3 times 2 plus 3i over n minus 2. And so you should simplify because you probably will in the test. So it's 6 plus 9i over n minus 2, or 4 plus 9i over n, like that. And then and then you go back, sorry, all the scrolling. Limit n goes to infinity, sigma I equals 1 to n, f of ci times delta x. And notice we have all of that now. So it's 4 plus 9i over n, that's the f of the I. The delta x is the 3 over n.
Yeah, that makes sense. Yeah.
So I think it'd be worth having you try one, maybe, at least doing some of the parts of it. So let's look at 50 together. I'll have you do some more of the steps here. Okay, so first thing is I want you to find delta x, which is b minus a over n, please.
How do we find n again? So
You don't, and n is just
oh,
there.
okay, so
Yeah,
it's negative
it's
2
got an
over
n in.
n. Okay. So negative 2 over n then.
2 minus 0 over n, so it's 2 over
Oh,
n.
so oops, yeah, okay, so it's
Yeah,
2.
a and then b, yeah.
Okay, yeah.
All right, so then f of ci, and your book might have something different. It's f of a plus I, b minus a over n, like that. And then so I want you to just do the part inside parentheses, just figure that out for me, please.
Or 2 over ni, or f equals.
So it's f of, right, 0 plus I, and then b minus a is 2 minus 0 over n.
Yeah.
So whenever you have a 0 in the a position, a lot of stuff goes away. So it ends up being f of 2I over n, like that.
Okay.
Okay, and then this is your f of x up here. So your f of x is 5x squared plus 1, and you have to put this, you have to find f of 2I over n, which means putting that in for x. Like that.
Right.
So could you simplify that for us, please?
Two I squared over n squared plus 1, or 20I
Yep.
squared over n
Yeah,
plus
there you
1.
go.
Yeah.
There you go. Yeah, 20I squared over n squared plus 1. Good. Okay, so now the last part is filling in, filling in the pieces. Sigma limit as n goes to infinity, I equals 1 to n. That's always the same. And then you put in the 20I squared over n squared plus 1 times, in this case, I believe it's 2 over n. Like that. I think that's what we got. Yeah, 2 over n for delta x. So the other thing that could happen is that you could distribute this in. I mean, there's a lot of possibilities here. So just keep that in mind. Like it could be 40 I squared over n cubed plus 2 over n. They could even make a common denominator in some sort of weird scenario.
Okay. Yeah.
Why don't you try 49 now on your own and work it out as far as you can, and then I'll work it out as well when you think you've got it. It's a little easier than the last one.
I squared over n squared plus 2 times I over n.
Like this.
Yep.
Okay. I think you mean 1 over n maybe.
Oh, yes. Sorry. Yeah. Add a dot
So
over there.
yeah, delta x is 1 minus 0 over n, 1 minus n. And then it's f of a plus I b minus a over n, like that. So it's 0 plus I 1 minus 0 over n, which is f of I over n. And that's what you put into the equation here. So it's I over n squared plus 2 I squared over n squared plus 2 times 1 over n, which is what you said here. Good. Yep, that's it. I mean, there's no tricks. There's no, it's not a magic show. There's just doing that. Now to actually determine the limit is a lot harder, but you like, so what it is that this becomes the integral. And I don't really know if you're, well, that's the end of the assignment. I don't know if the next section even addresses that, but the limiting process, the sigma n equals 1, I equals 1 to infinity, limit n goes to infinity, becomes the integral from a to b. But you'll have to look and see if your next section covers that at all.
Yeah, he hasn't posted the next section. Usually I send you 2 sections worth of work, but today he only had 1 posted. He didn't have 2, so.
All right. A little time left. Anything?
Nope, I think that's it. That's
All
good.
right. Well, we'll go ahead and stop here for today. So our next lesson is tomorrow at 11.